Additive manufacturing process. Nowadays, many rapid prototyping techniques are available. Even however, all employ the following process. The steps are: first one, conceptualization; second one, CAD; third one, conversion to STL; fourth one, transfer to additive manufacturing; fifth one, STL file manipulation; sixth one, machine setup; seventh one, build removal and cleanup; eighth one, post processing. This is a block diagram of showing the process, rapid prototyping process. Conceptualization. The first step in an additive manufacturing process is that one needs to imagine and also develop a thought about the function and appearance of the product. This may be in the form of textual descriptions, sketches, three-dimensional computer models. Conceptualization is done through making 3D CAD model using CAD programs. CAD. After conceptualizing object to be built, modeling is done using a computer-aided design software packages. Solid modeling packages like SolidWorks, Pro Engineer, CATIA, and Unigraphics are used to represent 3D objects more accurately than 2D wireframe modeling packages and gives better results. The pre-existing CAD file is used to create prototypes. Conversion to STL. Additive manufacturing technology uses the stereolithographic standard triangulation language STL. The file format. STL format captures surfaces of the 3D model by stitching triangles of various sizes on its surfaces. The spatial locations of the vertices allows preprocessor programs to determine the spatial locations of the part in a building envelope and also locate the surfaces of interiors in part. The limitation in STL is only geometry information is stored in files, while all other information of CAD model is eliminated, such as color, material, etc., which plays a critical role in surface finish of additive manufacturing part. The AMF format was developed specifically to address limitations of STL format and is now the ASTM or ISO standard format. This format addresses dimensions, color, material, and additional information with a file format. Number of CAD program companies, including several major programs, included support of AMF file formats. Transfer to additive manufacturing. Once a correct STL file is available, a series of steps is required to transfer the information to start the build. The needed information varies depending on the technology. These steps start by repairing errors within the STL file, such as gaps between surface triangle facets, inverted normal, where wrong side of a triangle facet is identified as the interior of the part. After repairing errors, proper orientation of the 3D model with respect to the build platform is decided, and orientation, geometry, densities or structures are decided and generated in 3D model. STL file manipulation. Next step after transfer to additive manufacturing, CAD model preparation starts with importing an STL file into the pre-process software program. After importing, the dimensions can be modified accordingly and number of steps are carried to correct errors. The file errors include missing triangles, inverted triangles, transverse triangles, open edges, and contours. These error types will cause problems in the building process and result in incorrect parts and geometries. Machine setup after STL file manipulation, machine setup is done through dividing in two groups of tasks such as machine hardware setup and process control. Machine hardware setup. Hardware setup includes cleaning of build chamber, loading of powder material, a routine check of critical build settings, and process controls such as gas pressure, flow rate, oxygen sensors, etc. Process control. The tasks in the process control group allow an additive manufacturing systems to accept and process build files, start the build, interrupt the build if required, preparing the machine for finished part extraction, unloading of material. After physical locations are decided, we follow a series of steps to define build process parameters, material parameters, and part parameters. The build process parameter controls machine level parameter that is applied to the entire build. Material parameters control powder dosing behaviors and chamber environment control through inert gas injection. Part parameters are assigned to each and every component part to be built. These parameters are taken into account in the slicing process that takes place in the previous step of the process chain. Support generation. The primary function of the support generation is extract heat, provide surfaces to build plate to avoid warpage from thermal stress which occurs after build. Generation of support structures in powder bed processes can be done in two ways. The first way is generate the support structures during CAD modeling and design the support to be features of the geometry of the part. Another way in support structures can be generated in STL process software program. Build file preparation. After generating support to part for creating build file, the slicer program divides the model layers in the build direction for required thickness. The thickness of layer should always be larger than the mean diameter of powder for achieving high coupling of laser energy input into the absorption, heating and melting of powder. Parameters that determines an amount of energy incident onto the powder bed per unit time are energy input, beam powder, beam power, scan speed, and focus move. After generating slice information, part is transferred into the interface program that runs on additive manufacturing systems. The interface program serves as the interface between information of the build and machine control which carries build process. Build removal. The build time of the powder bed process depends on a number of factors. The main factor here we see is the height of the entire build, which has an effect on the total time. It can take anywhere from minutes to days. After build completes, unpacking of the build chamber is done and we retrieve finished part. The unpacking process typically involves raising the platform in the build chamber and removing loose powder at the same time. Once the loose powder is removed from the finished part, the build is ready for post process. The finished parts at this point for powder based polymer metals are removed by chemical technique, and for metal powder we use cutting tools such as bandsaws or wire iridium for higher fidelity and flexibility. Post processing, depending on additive manufacturing technology, post processing techniques can be varied in a wide range. Post processing step sometimes may require no post process operation or may contain several additional steps to change the surface, dimensions, or material properties of the built part.